Good morning. It's Thursday, November 13th, 2013, from the International Space Station Flight Control Room. Welcome to today's edition of Space Station Live. This flight control team has been on console since early this morning, watching over station systems aboard an orbiting complex that's in excellent shape. Overseeing the team once again today is veteran flight director Ed Van Cise. He's joined today by astronaut Serena Auñón, who is handling the communications link between the team here and the crew aboard the International Space Station. That crew of 6 makes up Expedition 38 aboard the orbiting complex, commanded by Oleg Kotov. You see there in the center right of the picture seated. He arrived at the station with 2 other crew members, Sergei Ryazansky and Michael Hopkins, back on September 25th. On the left side of the crew's logo there is the 3 newest crew members. Mikhail Turin on the far left. Seated is Koichi Wakata, representing the Japan Aerospace Exploration Agency, and astronaut Rick Mastracchio, the tallest crew member. There you see standing in the back. These 6 crew members have been awake since about midnight. The 3 newest crew members ending their first week in space, 7 days now aboard the complex following their launch a week ago today. The other 3 crew members on their 49th day in space, they'll stay aboard the station until March of next year, when they relinquish command of the station to Koichi Wakata and Expedition 39 as it transitions to that number after their return home. All 6 crew members have a fairly busy day today. A lot of science activities going on that's being overseen primarily from NASA's Marshall Space Flight Center in Huntsville, Alabama. Once the crew members finish their early morning chores after wake up, they divide and conquer and head off in different directions. Wakata spent a good deal of the first half of his day in the Japanese science laboratory, Kibo, the Japanese word for hope, conducting some experiments, checking on others, and joining his colleagues for an early morning long-distance teleconference with the ground to set the stage for all of the activities on board. In the U.S. lab, much of the time spent today is on breaking down some experiments that have already been underway, including some work on the in-space experiment, a colloidal fluids experiment, also working with the a facet experiment known as investigation of mechanism of faceted cellular array growth, investigating the phenomena of solid-liquid interfaces for crystallization. The crew members also working on a crystal growth mechanism, crystal growth experiment known as ice crystal, which is essentially studies the stability of ice crystals in supercooled water, including antifreeze. This designed to help understand how these different types of solutions are required to be modified for use on Earth, and what we can learn in the microgravity and space to more purify such crystals. So those are just a few of the experiments that the crew members are interfacing with throughout their day today. They also, of course, have some other activities scheduled, a lot of human research experiments. Periodically, the crew members test each other for their eye acuity, if you will, and today marks one of those days where the periodical checking of their ocular health through blood pressure and tonometry, which is essentially an intraocular pressure test that's conducted on the crew members' eyes to understand changes in their eyes and their visual acuity throughout the duration of their stay aboard the station. So a busy day for crew members. In and around that, they of course perform their routine exercise. The newest crew members are allotted some time for continuing to adapt to the station and learn their new environment, which is their home for the next 6 months aboard the International Space Station. outside the orbiting complex, this view from a vantage point of 260 miles above the northeast coast of Canada, swinging out currently on after making a orbital pass almost all the way across Canada, skirting along the coastline of Nova Scotia, beginning a southeasterly trek that will take it across the North Atlantic, and then down across the Southern Atlantic along Ocean Pass, with the next coastal crossing being Australia, after skirting South Africa, heading into an orbital sunset about 44 minutes from now. These views courtesy of external cameras that are strategically placed on the outside of the International Space Station. A lot of these cameras were installed during the construction of the complex that began obviously way back in 1998 with the launch of the first element launch, Zarya, coming up on the 15th anniversary, in fact, of the first element launch from the Baikonur Cosmodrome atop a Proton rocket. Zarya was launched into space, checked out, and then about 2 weeks later, Space Shuttle Endeavour launched and arrived with the second component. So the actual start of assembly in terms of the mechanical interfaces began during that mission in December of 1998. So all of those anniversaries coming up to culminate in the 15th anniversary next week on the 20th with that first element launch to celebrate that activity. But as the station grew, cameras were installed along with the components that arrived to not only be able to offer these beautiful views of the Earth from this high vantage point over the Earth, but also for obviously for situational awareness. The cameras are used for astronauts and cosmonauts inside the station to allow for the assembly process to go more smoothly, with their basically being able to follow along with monitors inside the station, similar to a closed circuit television system. Those camera feeds are obviously also sent down to the ground so that flight controllers also can have the same situational awareness throughout that process. The cameras now are used for any external maintenance activity that requires on board the station, as well as providing views such as this from those cameras. In its current form, the International Space Station has a mass in space of about 900,000 pounds now. That changes just about every time a visiting vehicle either arrives or departs. This past week, obviously, the Soyuz 36 TMA-09 or 35 TMA-09M spacecraft returned home with 3 crew members, leaving behind the configuration you see here. The Progress 52 is a supply vehicle which is identical in size to the Soyuz. It launches on the same rocket, bringing supplies to the space station and then carrying away unused or unneeded items that burn up harmlessly in the atmosphere upon its re-entry over usually the southern Pacific Ocean. The 2 Soyuz spacecraft obviously remain at the station for as long as the 3 crew members are there, in which the Soyuz delivered them to the station. The Soyuz, most recent Soyuz arrival, Soyuz 37 TMA-11M, you see there docked to the Rassvet module MRM-1, which is basically one of the 2 mini research modules launched to the station by the Russian Space Agency atop Soyuz rockets. The MRMs provide a docking interface to the station, also some stowage capability as well. The other Soyuz, obviously Soyuz TMA-10M, was docked or is docked to the MRM-2, or the Poisk module. Poisk is the Russian word for explorer, and Rassvet is the Russian word for dawn. These two provide the docking interface for the Soyuz, as does another docking port on the back end of the Russian segment of the station, the Zvezda module. That port right now is clear and awaiting the arrival of the next Progress supply vehicle scheduled to arrive at the station a little bit later this year. Currently, later this month, I should say, somewhere around the end of November, with a current targeted launch around the 25th. Of course, there are other visiting vehicles of the International Space Station. Obviously, the commercial cargo program is now in full force with the institution or the inclusion of two additional cargo vehicles to those provided by the station partners, those being the Space Exploration Technologies, SpaceX Dragon capsule delivering cargo to the station, and also has the ability to parachute to a safe landing, returning cargo to Earth, and that includes obviously experiments that have been performed on board and samples that have been processed, both for companies that have executed those experiments on board, and also human research samples that the crew members collect periodically, such as blood and urine samples. The other cargo vehicle, obviously, that has demonstrated its ability to launch, rendezvous, and berth to the station is that of Orbital Sciences Corporation, the Cygnus spacecraft. Those two are spacecraft that rendezvous at the station, and they are berthed after being captured by the station's robotic arm by crew members inside the station, using those external cameras for situational awareness in the berthing process. The partner cargo vehicles include the automated transfer vehicle supplied by the European Space Agency and the H-2 transfer vehicle, or HTV, cargo vehicle provided to the program by the Japan Aerospace Exploration Agency. Those so that's the complement of cargo vehicles that are available to deliver cargo to and from the station. So that's the complement of cargo vehicles that are available to deliver cargo, as mentioned. And today, NASA will mark that significant milestone of the completion of the Commercial Crew and Cargo program with a news conference that you'll want to tune in for, scheduled for the scheduled at 10:30 Central, 11:30 Eastern Time today. That's why we're on the air a little bit earlier, so that we're clear of that news conference that will essentially celebrate the official conclusion of the Commercial Crew and Cargo program. Obviously, there's a long way to go in terms of the Commercial Crew program, which is a separate program working toward a commercial effort to provide spacecraft and launch vehicles for crew transfer and augmentation to and from the International Space Station as well. as mentioned in its current configuration of that you saw a few moments ago, the station usually hangs in around 900,000 pounds of mass in space. That changes up and down depending on the arrival and departure of those various vehicles. And it should stay pretty close to the configuration that it currently is in until new components, permanent components, are delivered to the station. But as of now, in this state, the end-to-end structure that you see that looks what we call the truss structure extends 357 feet tip to tip, and that includes 4 pair of solar arrays. Those each stretch 240 feet from tip to tip. The solar arrays obviously collect solar energy and store that in batteries that are housed inside the truss elements of the station, and that power then is transferred, obviously, and converted into usable electricity for the conduct of all of the power that's required aboard the station as well. And then you see the pressurized components. Obviously, that's the interior volume of the station that provides the protection and shirt sleeve environment for the crew members of the station. Currently about 13,500 or 13,600 cubic feet of habitable volume. Obviously, the overall cubic feet of the station is much larger than that, and that's measured all the way out to the walls of the complex, even behind the racks. So there's a habitable volume, and then there's a total cubic footage or feet volume of the station, very similar to in your home. If you measure square footage, that's out to the walls, but it's with cabinets and appliances and equipment, you can't necessarily reach those areas, but that's essentially the same state that you see of the International Space Station. Koichi Wakata, one of the newest arrivals at the station, although not a new crew member to space nor to the space station itself, having served on another long-duration expedition on the station, is on his 4th flight now into space, and he is currently in that Kibo laboratory, the 37-foot-long Kibo, which stands for hope. The Japanese word for hope has about 32,000 cubic feet, or has about 32,500 pounds of mass of the station.
For SSC questions.
Delivered back in May of 2008.
Oleg and Sergey. Go ahead. Ready to start com check work. Hi, this is Vladimir Kalganov. Again. Oleg, maybe you should do step 2 of the radiogram, MVS mode activation. And Sergey, when we are done with MVS, then Sergey will activate retranslation 9 will work relay program. All right, copy. We'll do that.
Because right now it's not logged in.
And no worries, Mike. We can log in remotely.
Okay, copy. All yours.
As you hear there, there are various, in addition to all the other nuances of the station, there's also 4 different communications channels, and those can actually be divided out so that different partners can talk to different crew members on board. It comes in very handy during periods where there's quite a bit of experiment work going on. It allows for essentially a dedicated channel for the Russian cosmonauts on board to talk to their flight control team that's located in Korolyov outside Moscow. That location, about 15 to 20 kilometers outside the city limits of Moscow, has been the home of the Russian Mission Control and its human spaceflight program for many years. And so they stay in fairly close contact with the Russian cosmonauts that is required for any work that's ongoing, experiment work and maintenance work on the Russian segment of the station. And of course, from a payload standpoint, most of that activity, you'll hear conversations from the Payload Operations Integration Center, or the Payload Control Center that's located in Huntsville, Alabama, at the Marshall Space Flight Center, which essentially oversees almost all of the experiment work on the station, coordinates that in terms of crew timeline, and so there's quite a bit of interface with experiments on board. The newer communications channels that are available allow for an experimenter, a principal investigator, to actually talk directly with the astronaut or cosmonaut that may be working on his or her experiment directly. So you hear quite a bit of conversation associated with experiment work going on board. And of course, as we continue to see Koichi Wakata in the Japanese laboratory, he obviously, when he's working on experiments as he was today in the Kibo module, working with the Japan Aerospace Exploration Agency and the principal investigators associated with those experiments as well. Yeah, I saw it while I was.
Ретрансляцию включил.
Relay mode is activated.
На пульте абонент 3.
3 is repressed, right?
На пульте абонента 2.
3. Нет, на пульте абонента 3, третья линия.
Line 3 on panel 3.
Да, все нажат.
Yes, all done.
Все принято. Значит, Олег.
Copy. Oleg.
Что тогда?
Да, уходим на третий шаг. Включаем МБС, да, третий шаг.
To step 3.
И включаем УКВ.
And activate UKV.
Да, все понятно.
Copy and work.
You're hearing Oleg Kotov, who is the commander of Expedition 38, talking with his flight control team. They're essentially doing some system checkout and reconfiguration inside the Rassvet module, that mini research module, to which is docked the Soyuz TMA-11M spacecraft, in which Mikhail Turin, Rick Mastracchio, and Koichi Wakata arrived a week ago.
Как меня слышно?
Mission Control Moscow, how do you read me from Soyuz?
Слышим тебя с интересной помехой.
We hear you with some interference. Let's try again. Oleg.
Как слышно?
Check, how do you read me?
Да, слышим тебя, но
We read you, but you have some interesting interference.
Значит так, давай сейчас. Ты нас слышишь нормально?
Да, хорошо.
Хорошо, понятно. Значит, да,
Interference.
переходим на резервный передатчик.
Let's go to
Четвертый дело.
backup transmitter. Step 4.
Удалил.
Okay, and work.
And while Kotov continues with those systems checkouts, his colleague Sergei Ryazansky is just about to complete a battery pack discharge on one of the Orlan spacesuits, the Russian version of the EMU for spacewalking that was used this past Saturday by himself and Kotov during that spacewalk out of the Russian segment of the station. That's also routine maintenance to recycle those suits and the batteries to ensure that they're in good shape for future use when required.
Let's go.
Mike Hopkins in the U.S.
In work.
Laboratory is getting ready to conduct a setup and checkout of the combustion interface rack or the combustion rack inside the station for future use as well.
No problem. So now it is great. Acoustic backup is perfect. Talk a little longer to make sure.
Посчитать не будем, да?
Maybe you count. No, we just you're loud and clear. You're good.
Слышим хорошо. Значит, давай так.
Loud and clear.
Вернемся
Let's do this.
на основной передатчик.
Let's go to the main transmitter.
На основной комплект передатчика.
To the main transmitter setup.
Station on 2 for service.
Okay. Switching to the main.
Good afternoon, Mike. If you're looking for a go at 1.3 and 1.4, you've got it.
You read my mind. Thank you very much, sir.
You're welcome.
Как меня слышно?
How do you read me on the main transmitter?
Великолепно.
Perfect.
Ну, я думаю, что
Okay, very good.
в этой комбинации очень хорошо.
I think this combination is nice. Let's go to the main backup of acoustic backup main in work.
Как меня слышно на основном комплексе?
How do you read me on
Слышно прекрасно,
main
Олег, великолепно.
acoustic?
Вот, ну что,
Just great.
ну,
Very good, thank you.
что-то, кажется, у нас в блоке акустики какая-то бородашка завелась. Да,
Well,
бородашка завелась.
but there was some interference there
Я понимаю,
Егором
в общем-то, ты понимаешь.
that confirmed me.
Акустики, поэтому ну,
Well,
влияет даже выключение питания системы. Видишь, как живучий попался, бородашка.
we'll see how it goes.
Включение происходит.
Maybe something's happening when we activate. Anyway, we'll troubleshoot.
По крайней мере, не страшно, но
It looks good right now.
летают рассвет РБМ новые системы, и блоки летают первый раз,
See,
поэтому
these are the first
очень так внимательно. Более того,
time in orbit units. That's
поэтому,
why
значит, остаемся пока в такой же конфигурации.
we'll stay in this configuration for now.
Заключительная операция.
Let's do cleanup.
Отключаем все. Вот. Мы получили результат, называется.
We have the result that we wanted,
Отключение, которое у нас есть. Вот.
and we'll
И дальше
still
тогда будем думать, что дальше делать.
experience that interference, but I think we know how to take care of it. Very good.
Все тогда, Олег, ну тогда все, тогда уже, я так понимаю, выходишь из СМа, все, но мы
I think you are leaving this module now,
вернуться в штатную конфигурацию, отключить ретрансляцию.
and we'll go to the nominal configuration, deactivate relay. How are you doing there? I'm doing good.
С гномом, значит, с гномом я это вопрос, да, в общем-то, вот, у меня здесь целый паровоз немножко такой, что надо оттуда исключить, оттуда.
And what about
Я
GNOME?
понимаю, что там бывает, то есть 4 разъема открутить все.
Actually,
4 болта, я
the work is in process. I understand that the four connectors will need to be dematted. We'll see.
не так
We're just, well, we are in the process of resolving this.
Это история, как говорится, такая уже.
We already
Отечественная. Ну,
have some
надо ее, конечно, демонтировать. Сейчас
history, but we need to take it off eventually,
не надо исключать.
for sure.
Это немножко целый паровоз.
But that will require also some additional operation. How about we'll just unscrew this GNOME and dispose of it, and then you will
Да, я все
exclude it from the system. I understand what you are saying.
Что, да, могу сказать, что я могу сказать, да, что я официально, так сказать, это...
But a final decision has not been made yet.
Yes.
I copy. Thank you. I'm
Сереж, да.
signing off.
Давайте. Олег, Сергей и Олег, давайте, отключаемся, все.
Yeah, both Oleg and Sergey, okay? Yes.
Сереж, а можешь еще разочек вот ответить?
Actually, Sergey,
Попозже, когда отключишь, тогда все.
we can probably talk to you after
На вопросик.
you deactivated everything, right? Okay, I have a question for you. Okay, fine.
And while that conversation's ongoing in the Russian segment of the station between Commander Oleg Kotov and his flight control team in the U.S. Laboratory stationed at the Combustion Integrated Rack, the CIR as it's known, aboard the International Space Station is Mike Hopkins, flight engineer number 3 of the station. He's setting up through the computer, reviewing the procedures that he'll be following.
Question. You heard that interference, right? Yes, I did.
We're just checking that the combustion chamber pressure was equalized.
And that's affirmative.
Okay, copy that. Proceeding to step 2 of the SIR open combustion chamber front end cap.
Copy that. Thank you.
The racks that are located along the walls of the space station laboratories are actually obviously racks that go around 4 different sides, because in the weightless environment of space, pretty much every area can be utilized. There is no floor, if you will, but in this case, that combustion integrated rack requires Mike High is usually closed. Obviously, it requires Hopkins to open that the doors that protect the equipment there that you see.
I am currently working on step 1.4 and then correction 1.6. And storage nodes show the releasable wire tie in the node 1 overhead for Charlie 1 in a CTB 1363. I could not find a releasable wire tie. Only thing that I found was this red wire tie. And is this acceptable to use this wire tie for the step 1.6, or I can use a Velcro strap to secure the inverter GFCI cable onto that 120 volt AC inverter. You have a video now from JPM?
Yes, now we are observing from starboard camera.
Okay, I will bring it to you close to the camera.
Thank you. We can clearly see it. We will think here.
And a very good example of how the crew members are working in different areas of the station. Koichi Wakata, flight engineer number 6, in the Kibo laboratory, cleaning up after some experiment work earlier in his day, referencing a CTB. That's a crew transport bag that you see him with there.
When we have to release it, I think you have to use the scissors. So that's a different. But you can tie for now for using the wire tie.
Okay, copy that. Thank you.
In the far distance there, you see the small airlock that is a unique component of the Kibo laboratory that actually allows crew members to place experiments inside that airlock and then close that hatch so that it can be depressurized to the vacuum of space without taking any pressure away from the overall station complex. For reference, the station's atmosphere is usually kept around 14.7 pounds per square inch, which is what you would feel here on Earth at sea level.
At the end. So I just wanted to make sure that the figure 2 is not showing the correct configuration, and the figure 1 shows the correct configuration. Could you verify?
The correct connection is shown on figure 1, so please connect to J4.
Okay, thank you.
And then down the hallway and around the corner from where Koichi Wakata is, Mike Hopkins back at the Combustion Integrated Rack, or the CIR. He is actually preparing that facility for some hardware replacement associated with the multi-user droplet combustion apparatus known as the MDCA, which is part of that combustion integrated rack. It's basically housed within that. It's essentially a multi-user facility that's designed to accommodate different types of droplets for combustion science experiment or flame experiments that can be conducted in an extremely controlled environment. The conduct of flames in space is essentially a study that helps to understand what happens to flames in space and how that can be translated to what happens to flames here on Earth. So periodically there are a number of experiments that are conducted associated with the combustion integrated rack and the combustion apparatus that Hopkins is preparing to work with today. Today is essentially a maintenance day with this experiment rack, not experiment work itself. Obviously, anytime experiments are conducted, there's an extensive amount of time set aside to set up for that experiment, no different than what would happen on a daily basis in science laboratories here on Earth. And he's joined by Rick Mastracchio, who arrived at the station a week ago this Thursday, November 7th, after a late Wednesday night launch from the Baikonur Cosmodrome. Mastracchio on his fourth flight into space, but his first 6-month stay. Basically, his 3 previous flights, all to the International Space Station, were short, by comparison, short space shuttle flights, assisting with the assembly process of the station. His most recent visit was STS-131, which flew in April of 2010. So Mastracchio now, instead of being a short-term visitor to the space station, will call it home for the next 6 months. He, along with Wakata and Soyuz Commander Mikhail Turin, are scheduled to stay aboard the station until next May, with their current return date targeted for May 14th. So they're just now getting started, settling in on a 6-month stay aboard the station as scientists and members of the Expedition 39 crew when they transition to that after Expedition 38 departs in March. And Wakata will become the first Japanese commander of an expedition crew aboard the station. Mastracchio, just a few moments ago, was wrapping up one of his 2 exercise sessions for the day. Each crew member is provided in his timeline about an hour, 30 minutes to an hour, depending on which exercise routine he's performing during that time frame for exercise, which is a critical component of long-duration life in the microgravity environment. His session that wrapped up it may not have occurred yet. It's scheduled to occur in the time frame from between now. He's got basically about an hour and a half scheduled for what's known as ARED exercise. That's a resistive exercise device on the station that's essentially allows the crew members to simulate weightlifting, because without that their muscles would begin to atrophy, very similar to what happens to us on the ground as we age over long periods of time. The same changes occur with astronauts and cosmonauts in a very short period of time. And over the years of human spaceflight, doctors and biomedical engineers have done extensive studies on the countermeasures to those changes, so that particularly when these crew members return home to the one gravity environment, they can readapt much more quickly, and they don't tend to have as severe the symptoms of returning to Earth, and obviously the rehabilitation period can be shortened as well. No different than if you exercised every day for 6 months and then took 6 months off and tried to get right back into it. Obviously, that would not be the most appropriate approach to getting into a routine of exercise. And so these crew members are strictly budgeted for exercise twice a day aboard the station to maintain their musculoskeletal systems and also their cardiovascular systems via a onboard treadmill. They also have a cycle ergometer so that they can maintain their cardiovascular systems through a cardio routine as well each day. Six-person cruise aboard the International Space Station is something of a routine now, with even with the indirect handovers. And so these 6 crew members have been together now for about a week. And of course, they will remain together until March as Expedition 38, and then transition to Expedition 39 after that. Let's take a look at the mission of Expedition 38.
The goal of the International Space Station's Expedition 38 is to conduct science research that's not possible on Earth, and to learn what it will take to protect the human explorers who will make voyages of discovery beyond low Earth orbit in the years to come.
We need such flights to understand how to make a long-term existence of a human being in space safer.
So the crew members are test subjects for dozens of experiments to quantify the physical effects and test countermeasures to reduce or reverse those effects. For example, scientists are working to find out if certain foods can stop the loss of bone mass.
That's where we're looking at the ratio between animal proteins and potassium and how that affects bone loss. And so the idea is that if we can figure out what that right ratio is, we might be able to minimize the bone loss through just nutrition.
We will be measuring our physiological data related to the changes in the eye and the brain due to the change in the intracranial pressure in the microgravity. And by consistently gaining or measuring this kind of physiological data on our eyes and brain, we will be able to find out exactly what other causes are for the eyesight change in flight.
For another example, the research isn't just on the physical effects of being in space, though. There are experiments on the psychological ones, too, which could have applications here on Earth.
But if we're studying psychological aspects, they can be used not just in space exploration, but can be propagated and applied to human relations in general, and are much more in demand in various areas of our human activity, human life.
The station is also home to science in other disciplines, which are taking advantage of the unique environment in low Earth orbit.
For example, there's MAXI, which is looking at cosmic X-rays, and they've had some very interesting results. In fact, I think they were able to help detect a black hole shredding a star, and so that's just fascinating.
If we grow a crystal on board the station, the crystal will be of perfect shape. Crystals are used in the laser industry, in pharmacology, and huge protein molecules, which are very important in healthcare.
We're also looking at how pathogens interact with cells in a micro-G environment. And then on the other side of that, we have experiments where we're looking at how things burn, how things combust in space, so we can better understand why things ignite, how things burn, and then better understand how to keep materials from burning in whatever the situation may be.
Station crew members will attend to a whole range of science experiments during their stay on board. They've also trained for planned and potential spacewalks, and to receive shipments of supplies in a variety of cargo vehicles. By February, they'll be ready to watch some of another international gathering, the Winter Olympics in the Russian city of Sochi.
These two projects are devoted to the improvement of communication, interaction, cooperation, people, different countries, different cultures. That is why the Olympic Games and the station are very much alike in this sense.
Expedition 38 gives way to Expedition 39 when Kotov and his Soyuz crew return to Earth in March, and Wakata takes over, the first Japanese astronaut ever to command the International Space Station.
Japan is very happy to have this opportunity to have ISS commander from the Japanese Astronaut Corps. It's a big challenge for me, and I'm just fortunate to be able to learn a lot from my previous ISS commanders and shuttle commanders.
Wakata's crew will grow by 3 when another Soyuz arrives a few weeks later, carrying NASA astronaut Steve Swanson and Russian cosmonauts Alexander Skvortsov and Oleg Artemyev. Those 6 crew members will work together until Wakata, Turin, and Mastracchio head home in May, having made their contribution to achieving a dream of humankind.
We want to go out and see what's out there. We want to know more about things, and we can't just do that through robotic systems. We have to send people to see things up close and personal. So I think it's very, very important to get folks into low Earth orbit. It's very, very important to get folks beyond low Earth orbit. And this is just one small step in that long, long journey.
And that was a short look at Expedition 38 as it transitioned to that number this past Sunday with the return home of 3 crew members, Expedition 37. Fyodor Yurchik and Karen Nyberg and Luca Parmitano safely home Sunday night after 166 days. 2,600 orbits of the Earth and almost 70.5 million miles of travel. They leave behind a fairly perfectly operating science laboratory in space with 3 different science modules in which crew members are working during their day. Koichi Wakata in the Japanese science laboratory Kibo, Mike Hopkins in the U.S. laboratory Destiny, the first science laboratory delivered to the station as part of the assembly process. Destiny was delivered in February of 2001, Kibo in May and June of 2008. The third science laboratory we haven't seen in any of the camera views today is the Columbus Science Laboratory provided by the European Space Agency, delivered to the station in February of 2008. Columbus and Kibo had to wait until a connecting node providing docking ports arrived. That was the Harmony connecting node that was delivered ahead of those science laboratories in October of 2007. There's a very strategic approach, obviously, to the assembly of the station. The power grew, obviously, it had to grow more quickly than the arrival of the modules so that there was plenty of power available before those laboratories arrived as well. And then they each obviously went through an extensive activation process, and of course that included along the way the introduction of some new environmental control and life support systems on board the station, including a complete water recovery system. Water, obviously, one of the primary needs aboard the station for various reasons, but the new water recovery system allows for the recycling of water, both that accumulated from humidity out of the atmosphere through the air conditioning process, and also the recycling of urine, turning that into a purified drinking water aboard the station for use by crew members as well. Yeah, it has a complete enclosed, recyclable, and totally enclosed life support system for the crew members on the station, including a carbon dioxide removal system. Since there are no plants on board to absorb all of the carbon dioxide that the crew members breathe, that the devices on board take care of that for them. Hopkins will continue working with the combustion integrated rack for a good bit of the rest of his day. All 6 crew members will gather once again together for a daily planning conference, the second of the 2 that are scheduled each day, one in the morning, one in the afternoon, before they go to bed. The afternoon DPC scheduled for a little after 1 o'clock today essentially looks back at everything that the crew members have completed and gives them a look ahead at what's in store on their schedule for Thursday as well. Once that's completed, the crew members head off into what's known as pre-sleep. They essentially will get ready for bed and have some private time during the last couple of hours of their day before heading to bed at about 3:30 this afternoon Central Time. And then they'll wake up again to begin another day of work aboard the International Space Station about midnight tonight to start their Thursday aboard the International Space Station. And of course, we'll be back again for another hour of coverage tomorrow as well. But stay tuned at the bottom of the hour, news conference on the completion of the Commercial Crew and Cargo program. And then later on this afternoon at 3 Central, 4 Eastern, the launch of the MAVEN, which is the Mars Atmosphere and Volatile Evolution spacecraft. There'll be a Google Plus Hangout, so be sure to tune into NASA TV for that as well. So until tomorrow, have a great day. This is Mission Control Houston.